Hello, welcome to today's tutorial. Today we're going to talk about the circular perforations with size and density variations. Alright, let's start our today's tutorial. So the first step we're going to do is to create a square grid. And then we use that square grid as a basis to set up our perforations. So the size will be 100 mil, and then we have 100 squares to X extent, and then another 50 squares to the Y directions. So now you can see, the grid is set up, and then we use area to find the center of each of the squares and use these points as the center of our circles. Then the radius will be 35 now, just to visualize it. So now you can see a lot of circles have been created. So if you already have an existing facade or area they want to use for preparation, you can simply take it in, set anchor, so get it into the grasshopper, and then you can simply use divide surface. Divide surface. The U will be 100, V will be 50, and you got all these points as well, and then you can connect it back to the plans. So it will be the same thing. Alright, back to the topic. So once these circles are created, the next step we're going to do is to change the radius of the circles. So circles can grow from small to big, from the bottom to the top. So how to do that is actually to give all these circles in the columns a different radius. So we need to use series here to create 50 different sizes for all these 50 circles. What we do, the count is here, then we output the series to radius to have a look. Now we can have a basic sort of variations, but this is not what we want because we can't really control the size of the radius using this way. It's just not easy to control. So what we can do is actually introduce graph mapper. The graph type will be Bezier for now. You can now actually test out other formulas as well, but today we're using Bezier. And then the input is actually from 0 to 1. If you double click, we can the output is actually the y-axis, which is from 0 to 1 as well. Today we're going to change it into 1 to 2. I will explain why this 1 to 2 later. And then in order to get 0 to 1 input, we need to change the series, right? So what we do is we use 1 to divide 50. Actually, we use 1 to divide 49. Put it here, drag it back to B. Use 1 to divide 49, and then connect back to step. Then in this way, you can see the series output is actually from 0 to 1. And then we connect that to the graph mapper. And then the output for now of the graph mapper will be from 1 to 2 as we set up. 1 to 2 is so small for perforation size, so we multiply 1 to 2 by say 15, and then the output will be from 15 to 30, and then we connect back to the circle. Now you can see we have a much better variation. So we can easily change the number here to control the overall size. We can also change the shape of the curve here to control the variation gradient. I quite like this one, so I just keep it like this. And then the next step is to have a bit of fancy treatment to the bottom. So I'm going to introduce another battery called Random Reduce. Input the circle to the list. Reduction will be 10 for now. We prove it off. Then we can see, well, every single columns. There is 10 circles got removed because the seed for now is consistent one for all the columns. So pretty much all the circles at the same location have been removed. So what we need to do, we need to create 50 different seed for all these 100 different seeds to this 100 columns. So again, we create a series. The column will be 100, and make sure we use graph tree to graph it. So the output will be a tree as well to match the input list. Now we can see the circles have been reduced from different location, random location, because the seed is different. But then the reduction is happening across the whole pattern. We only want the bottom portion to have reduced circle. The top portion will be consistent perforations. So we need to divide the patterns into two portions. So what we're using is called split list. So we split all the circles from index 10 for now. Then the bottom portion will be random reduced. And the top portion will be kept because we need to reduce that reduction to 6 because the bottom portion only have 10 circles. We can't just remove all of them. And then we use merge. Merge the top perforations with the bottom. I'm going to change that into, if you double click it, you can change it into 30. The minimum will be, say, 0. Then we can change it into 15, 16. Reduction will be more as well. So you can see now the top portion is consistent, the bottom portion has been randomly reduced. But then I just realized the cutting line is just too consistent. It's still not very randomized. So what I'm going to do is to make that cutting line here randomized as well, which means the split index for all the columns will be varying as well. So how to do that? We still need to create another series here. The count will be 100 as well. Now this time we're not using series, we're using range to create a range of numbers. So the steps will be 100 again, but the domain is actually from here. We construct the domain, 2D domain, and then it will start from say 10. So for some of the column, the reduction will happen from index 10, and then another end will be 20. So for some of the columns, the reduction will begin from 20, and then we input all this 100 sort of splitting index back to our index. Make sure we're using graph tree again to match the tree data type. And now you can see we have a different reduction index, but it's still happening in a consistent way. So what we need to introduce is called jitter. So we jitter all the splitting index numbers. value back to here, and now this is actually the pattern that we want. But you may realize now the pattern it just curves, right? You know, for practice, you can actually send these curves to the manufacturer. They can actually use this curve as CAD to cut, the panel. But for rendering purpose, we need to change this pattern to a surface. So at first, we need to create a rectangular as basic surface. So rectangular, and then your x-size will be 100 by 50, which is your x-size. And then your y-size will be 100 by, the x-size will be 100 by 100. Then the y-size will be 100 by 50. Now we've got our boundary sort of rectangular. Then we use, you can drag it here. We use the boundary surface, and the edge will be all your circles and your boundary rectangular. Make sure you flatten them, and then you connect the output to the edge here to form a pattern. Make sure you save it before you connect, because it can be really heavy because you have a 5,000 circles here. So, but once you connect here and wait the computer to respond, and then you can get the surface. Let's wait for a moment. We have our surface ready for render. We can actually pick it out and then change it into render. Change the material color to, say, yellow. We can rotate a bit. And here we go. Thanks for watching today's tutorial. Please subscribe to support and check out my other videos.